Hello everyone, welcome or welcome back, either or. We have a fun one lined up. I think it's a fun one. It's a topic that I enjoy. It's a cool technology, and I'm hoping that you guys will feel the same way about it once we're kind of done. Might take us 2 videos to complete. This one, full disclosure, may end up being a little longer, maybe 40 minutes or so. We've got a lot to unpack here. I'm excited to get into it and show you. So I just wanted to do a really quick recap on where we left it. We had brought internet connectivity into Cisco Site A, right? And we had done some pretty cool stuff with SLAs and tracks so that we could essentially use the MPLS connection as a backup to our internet. So we dropped in direct internet access. So any and all internet traffic would go directly out the ISP that I have highlighted here in the topology. However, if it went down based on our SLA and our track, it would fall back to the MPLS cloud and find its way into the data center and route out through the firewall and go out to the internet that way. However, I want to ask you guys the question, what if the reverse happened? So what if the MPLS were to go down? Where would that leave our branch site and our fellow employees, or our customer for that matter? So essentially, any and all resources that they need to get to inside the data center would no longer be accessible if the MPLS were to go down. So wouldn't it make sense to take advantage of our internet connection in that site in some way, shape, or form to be able to offer a second path to the data center in the event that the primary were to go down? So that's what we're going to be discussing today. And we're going to be discussing Dynamic Multi-Point Virtual Private Network, or DMVPN. It's been a while. It's been around for many, many years. It's a tried and true technology, and it will essentially allow us to build an overlay network to access resources in any destination we choose, in this case our data center. So I do want to, before we jump into the actual DMVPN, or let me just demonstrate, let me show you one thing. I guess we'll knock this out of the way and then we'll start to do the configuration. So if you Google Cisco DMVPN configuration, or if you navigate to Cisco's site, you should find you'll either get this hit if you Google it, or if you go through Cisco's site, hopefully you will find this document. If you open this document, it is the full configuration guide for Dynamic Multipoint VPN. And if you do a Control F and type example, okay, you'll see that it highlights configuration examples for DMVPN. So if we click here, it'll jump down to the actual configuration, and they provide an example hub configuration for the DMVPN. And if you scroll down a little bit, they actually give you an example spoke configuration as well. So I'm not going to go through and try to teach the entire DMVPN concepts, if you will. This link I think speaks for itself. I can actually put this link in the description so that you guys can kind of go through it at your leisure. All I did was I took these examples, and they give you nice comments too. So it tells you, for like MTU, right, ensures longer packets are fragmented before they are encrypted. They give you nice explanations as to what each command does and why they're needed. So I think it's a really good document to keep in your arsenal, and why bother trying to memorize all these commands when Cisco puts them out here for you. So I copied them out into a notepad. I do need to discuss this as well. We'll get to that when we start the configuration. But for our hub, I've copied the configuration out and modified it to kind of apply to our topology. So I changed the key rings to just be all caps and something a little bit just more plain Jane simple. I've changed the profile names again to all caps and just kind of follow suit with what we've been doing to date. So this will be the entire hub configuration for DMVPN that we put on our WAN router. As far as the spoke goes, or spokes, This is the entire spoke configuration that we'll just basically paste into our branch sites, and we'll watch the DMVPN technology kind of come to life. We're going to get into the VRF. I had made mention of this a couple videos ago. I'll explain what we're going to do with that in a few minutes. But really quickly, what I want to do is, I want to go back to site B really quickly, and I want to just get the basic internet connectivity up, so like we did for site A. So let's just get a simple connection over to the second ISP here, and we'll just slap some IP addresses on there and just kind of establish that basic connectivity. So if we hop on to ISP B, show run interface gig 2. So there's nothing there. Let's just give him an IP address. Again, this is arbitrary. It could be whatever we want. Interface gig 2. No shut. IP address. Okay. And then why don't we, while we're at it, let's just go to BGP and advertise that network just to make sure that we don't create any holes later. Okay, so nothing new there, just basically slapping an IP address on. So now if we go to site B router 1, we're looking to configure E01. So E01 has nothing, so we're going to give that the other end of that /30. So interface E01, IP address was 202.222. And then we will just throw a default route in there to leverage that next hop. So we'll do IP route quad 0, and we'll basically send everything to 202.221. We won't worry about tracks and SLAs right now. Actually, you know what? We are going to do that. I wanted to demonstrate one thing with that. So can we ping the internet? Okay, we can, so that's awesome. So you'll recall I'm going to make this full screen, and I'm going to split site A and B so I can see both. So on A, we did show run include route. We put this IP route in for 8888. We chose a well-known internet address that most people know, and we chose it to essentially use for our SLA and our track, okay? A better way to do it may be to just use the other end of the /30. So in other words, don't make it a well-known IP. It might cause confusion later on for a fellow colleague or engineer or whoever. You know, at some point in time, they might wonder why they can't ping 888 if there's a severed connection or a black hole there. So it's just kind of, it may not be ideal to use that. So what we'll do is on this side, we'll just point the static route that we're going to use for our track to the service provider IP. Okay, so we'll basically do the 202.221. All right, so we'll say IP route 202.2.2.1. We're going to make it a /32 host route, and we're going to point it out. Or I'm sorry, we don't need that. My bad. All we're going to do is track the, because it's connected. So if we do show run section SLA and section track, okay, we're just going to kind of reuse this code, if you will. So we're going to do IP SLA 1, okay, but instead of doing the ping to 8888, we're going to do the ping to this guy, all right? So we got that. We'll start that. All right, so if we do show IPSLA summary, okay, we've got responses, that's good. So now we'll do the track. All right, so now we're tracking that reachability, and then for the IP route, we can now take that IP route and modify it. So we'll say name DIA track 1, okay? So that should cover us. So it's just kind of another way to do the track. It's the same concepts. You're just not using a well-known IP. You're just using the other end of your connection to your service provider, right? So if we show IP route, we have that static route in the table. It should drop out in the event of the SLA going down, which will cause the track to go down. So we can test that in a bit. So that's in place. We've got the internet in place. So the next step is, if we go back to our the hub configuration. So we're going to be adding what's called a front door VRF. So what that means in English is, if we go to the topology, and if we look at our WAN 1 router, okay? So the WAN 1 router sits in our data center, right? But just a quick reminder that it has private IP address scheme with EIGRP peerings to the core switches of our data center. So in other words, this is like the keys to the castle, right? All the IP addresses, VLANs, they're all kind of stemming from the cores. And this router is directly connected to those boxes. But now we're talking about adding an internet IP address to this router, which is not very secure if we put them all in the same routing table, okay? So the same concept we used in the service provider cloud to separate our customers, we're going to apply that same logic to our WAN router, but we're going to do it to essentially make the internet separate than the interior of our network, okay? So is it the most secure thing in the world? No, of course not, but it adds a layer of protection so that we aren't bleeding those routing tables together, so that we can try to protect those private routes or addresses at any way we can, right? So if we go to the WAN router, so at this point we can go back to our normal view here. So on the WAN router, what we're going to do is, if we show VRF, we don't have any VRFs configured, right? So why not just use the cheat sheet? I've kind of made note of what we're doing here. So we're going to define VRF INET. We're going to give it a simple route distinguisher, okay? So in this case, I just chose 101 because that's our public AS number. And then I just chose the route targets AS with a :1. So, and then we have to activate the address family IPv4. So let's go ahead and define that VRF on the WAN router. Okay, so the VRF's now there. Show VRF. We can see that it's now ready to go. Now, the reason we had configured the port channels to the edge switches several videos ago was to create or make our lives easier if we ever wanted to add services down the road. That's the whole point of a design like this, right? So we know that the internet comes in and we tag it as a VLAN, which gets trunked across whatever links we want to trunk it across. So in this case, we're just going to bring VLAN 901 down to the WAN router and basically do what router on a stick again, right? And we'll be able to then take an IP address that's in our public scheme, so the 101 dot space, and we'll be able to assign that to this router. So again, it makes it easy. We don't have to worry about somebody in the data center wiring something in. It's already there waiting for us. We can just do the configuration. So if we show IP interface brief, that port channel is already there, okay? There's nothing assigned to 901, so we're going to go ahead and we're going to basically go under 901. We'll do the VLAN 901.1Q tag. We'll put it in VRF INET that we just created, and then we're going to give it the IP address of 0.254 which is the last IP address in our public address range. So it's easy for us to remember it's the last one, and you'll see why I chose it when we get to the branch sites, okay? So let's go ahead and we'll slap that in the WAN router. All right. Now, there's one more piece to the puzzle as far as getting the internet connectivity for the WAN router out the VRF. So remember, as soon as we do the VRF, if we show IP route, we don't see the 101 space connected that we just defined, okay? Because this is the global routing table as far as our WAN router goes. If we do show IP route for VRF INET, now we can see that we have that connected route that we just defined, okay? But there's no default route to get out to the internet for this VRF. So let's go ahead and add that. We're going to use this syntax, IP route, VRF, INET, quad 0, and we're going to chuck it to the firewall. So that's the 101.105 is the firewall, all right? So let's just blast this into WAN router 1. And now we should be able to, so if we show the routing table, we now have the static, and we should be able to ping through VRF INET 8888, which we can. Okay, so we've just basically, we've taken the WAN router, we've put the IP address on it, and we've provided internet access to that router. So if we go to router 1 in site A, we should be able to ping 101.10254. That's awesome. So we need to have this reachability. That's the WAN router IP that we just defined, okay, in that VRF. We've now made that IP reachable through the internet, okay? So any one of our branch sites that has internet connection should be able to reach that IP. So let's just double check router B just to make sure he's happy as well. 101.10254. Okay, so both of our branches can reach WAN router 1. Perfect, that's awesome. So I had a note to show you guys the license activation piece, okay? So what I mean by that is the routers in the data center in this topology are the Cisco Catalyst 8KVs, okay? The CSR 1000Vs, it's a similar story with those, the cloud services routers. You need to activate the features and functionality for crypto for this particular config. So we're about to apply this configuration to our hub, okay? And as soon as we type crypto, the router's not going to understand it. So let me demonstrate. If I go to WAN router 2, I have not done anything with this router as far as activating any licenses. So if I go into conft and I type crypto, okay, and hit the question mark, you'll see that I need to be able to run the command crypto isocamp, but it's not in iOS help. So it's not there. And the reason for that is because you have to activate the features and functionality. So how do we do that? So if we go back to WAN router 1, okay, just to show you the difference, if I type crypto and hit the question mark, you can see there's a whole bunch more stuff available to us, okay? So in order to do the license activation, what you do is you go type license and you say boot level. We're going to use network advantage. Okay, it wants the keyword add-on, and then it wants the keyword DNA advantage. Okay, is it happy with that? It is. So if we hit enter here, it tells us that you have to use the right command to make the license boot config take effect on the next boot. Okay, so we're going to say right. So that saves everything we've done up until this point, and let's just go ahead and reload this box. Okay, and we'll come back to him in a minute, all right? So while he's rebooting, let's go ahead and paste the configuration for the hub into WAN router 1. So we'll do it in chunks. So the first thing we have to do is create the isocamp policy, which is going to define the encryption AES, pre-shared key, and the Diffie-Hellman group 14. So we're going to go ahead and just blast that on there. All right. Then we have to define the key, okay? And since we're doing front door VRF, we have to, there's two places that we have to tie in the VRF keywords. So if we go back to the Cisco page and we look at the hub, so we won't see any reference for VRF in here at all, okay? And you guys can look at on your own time. I'm not going to bore you, but trust me, there's no VRF keywords in this configuration because this example they're giving you is not using front door VRF. But the two spots that we need to apply the VRF keyword is the keyring. So we need to tell the keyring Cisco that it belongs to VRF INET. Okay, so we're going to go ahead and we're going to put this in our config. All right, so that's done. Now we have to create for the IPsec. So we're going to apply the IPsec transform set to the IPsec profile, which then gets attached to the tunnel. So again, that nested kind of functionality that Cisco uses in true Cisco fashion, they stick to their guns on it. So we are going to paste this in. We'll create the IPsec profile, which references the transform set that we just defined. So you have to do this in order, because if you go out of order, it doesn't know what you're trying to reference because you didn't build it yet. Most of the meat and potatoes is under the tunnel interface. So you can create tunnel whatever you want. So when I go into interface tunnel and hit the question mark, okay, you can use any, I mean, they give you a large range to define tunnel interfaces. So in Cisco's example, they chose the first one, which is 0. So we'll just do the same thing, right? So interface tunnel 0. Bandwidth, it's not a necessity, but it's nice to put on there. This is where we put a new, what's called an overlay IP address, okay? So since we're essentially going to be tying all the branch sites into the data center via DMVPN, you come up with a subnet. In this case, I chose the last range of the 10 dot, so 10.255, okay, because it's easy to remember. And I just made it a /24, which would allow me to have, you know, roughly 254 branch sites, if you will, right? Some of these addresses are going to be for the data center, so it's give or take a few. But this will allow you to build a deployment of a roughly 250 branch sites, okay? If you need a bigger subnet, you would adjust that to accommodate your needs, all right? So for the lab purposes, we're just going to make the first IP address belong to this WAN router. We'll make it a /24. The MTU, I'm not going to explain all these. I'll make reference of the link. You guys can look at the link and kind of read what the descriptions and all that stuff are and why it's needed. So I'm literally just taking what the site provided. So we're going to go ahead and just blast this on there. Okay, so in theory, our hub router is done, okay? Now the command that you run to verify DMVPN is nothing more than show DMVPN, okay? So there's a whole lot of nothing going on right now because we haven't configured any branch sites. So let's see if we can get the first branch site configured, and let's see if this output changes, all right? So we'll go back to router 1 in site A. Okay, so we're back on this guy. We've got the internet. We know all that works. We have reachability to WAN router 1. So that's all the groundwork is kind of in place. So let's go ahead and just throw the configuration on for the spoke. Now the spoke does not have the VRF because it's not necessarily needed. You can put a front door VRF on the spoke as well and do it that way. There's nothing wrong with that. In this case, I'm not doing that because the internet is... there's the NAT boundary and everything else anyway. Again, still not the most secure, but there's no real need for it. So I'm going to go ahead and just take this entire config and just paste it on there. Okay. So we'll get a couple console messages that come across that tells us ISACAMP went from off to on. We've got line protocol comes up on tunnel 0. Okay. What happens on the WAN router? Sorry, that was O2 that just rebooted. So no real messages on WAN 01. yet. Okay, so let's come back here. Let's do a show DMVPN on site A router 1. And we can see that it's doing something, right? So it's trying to establish a connection. Okay, so this should come up almost immediately if it's configured right. So the fact that it's in state IPsec tells me that there's a misconfig somewhere. So let me take a peek at the hub really quick. I have a suspicion I know what it may be. So we have the key ring is tied to VRF internet. I had made mention that there's 2 spots that you need to attach VRF commands to. The other place is under the tunnel. And I don't see, right. So under the tunnel 0, this should do it here. So interface tunnel 0. What we need to say is for the tunnel, the VRF is INET, okay? So let's put that command in. Okay, that's maybe better. We've got nice account message that came across. If we go back here and we hit the up arrow, now we're in state IKE. Still nothing hub side, show run, section, crypto. Okay, looks like it may, okay, did it just come up? Okay, good. So that's what we're looking for. So when we do show DMVPN, okay, we want to see that all the peer addresses of tunnels that we may or may not have, right? They'll tell you that this is the public address of WAN router 1. This is its private overlay IP that we defined. We can see it's been up for 7 seconds. And you can see that this is a static peer, if you will, okay? If we look at the WAN router 1, show DMVPN, we can see that we have a peer for 200.0.1.2. That's the public address in site A. We gave it 0.3. That's what we gave the spoke site right here, okay? It's been up for 38 seconds, but look at the attribute now says D, which is dynamic. So hence the term dynamic multi-point VPN, okay? So let's go ahead and get site B. Let's get him in the mix here. So we did our basic internet connectivity, right? So we should be able to ping 101.1.0.254. So we have reachability to the data center from site B. So the only thing we should really have to tweak here is the IP address. So we can make site B.2, okay? But as far as all the cryptography stuff, it's all going to be the same. The tunnel can still be 0. This is the tunnel address and then the public address. So that's one thing you'll just have to keep in mind, and it's in the description of the Cisco site. We just have to check our source interface as well. So it's ETH01 goes to the internet, so that should be okay. All right, perfect. So let's blast this on site B. All right. Show DMVPN. Look at that. We've got a peer. That's awesome. Static. Okay. So the thing that I wanted to demonstrate here, so if we go back to WAN router 1 and we hit the up arrow, we should see 2 peers now. Okay. So we can see that the 2 public addresses of the branch sites and their overlay private IPs, and they're both upstate and they're both dynamic, okay? Because the spoke site reached out to the data center and asked to form the VPN tunnel, which is why it's dynamic from the hub side, okay? From the spoke side, it's static because we had to tell it where to go to establish the connectivity. So the last piece, or the cool part of DMVPN, is that it allows spoke-to-spoke connectivity directly between one another. And this is where it comes in the dynamic naming nomenclature as well, right? So watch what happens here. So on in site A, router 1, I'm going to ping the tunnel address of site B, which is 10.255.0. Well, what do we make it? 2, right? 10.255.0.2. So I'm going to ping that address, okay, from site A. Okay, awesome. So I have connectivity through over the DMVPN to the private address in site B. Now check this out. If I do show DMVPN again, look at that. It created another tunnel automatically, okay? As soon as I launched that ping to the hub used the next hop redundancy protocol, and it was able to say, no, I know a better way for you to get there. You want to just talk to that site directly, okay? So that's what the magic of DMVPN is. It'll spin up these tunnels dynamically, and now the branches can communicate directly with one another through the underlay transport, in this case, internet. Pretty awesome. So if I do show DMVPN on site B, it also has the second tunnel as well, okay? And you can see now it's dynamic, okay? Which is pretty cool. I wanted to just kind of make sure that I demonstrated that so you guys got like the full picture. Now, the next thing that we're going to start to do, and we'll probably tackle it in the next video because it's going to be a bunch of routing changes. But what happens now is that we can start to incorporate one protocol across the environment. We don't need to worry about doing all this route redistribution between BGP and EIGRP in various places, or worrying about getting static routes into the protocols. We can start to make our lives easier. So in the next video, I want to try to tackle essentially turning on EIGRP at the branch sites, because right now we don't have it, right? So if we show IP protocols, we don't have EIGRP running, okay? We have BGP and we have NHRP, which is a result of the DMVPN that we just did, all right? So show run section EIGRP, there's nothing there, it's not there. So you remember like a while back, we had configured all these sites to just do fancy static routes, right? So in order to reach the data center, right, we have a static route. So we want to ultimately get rid of that. We want a protocol to do it all automatically, all right? And that's, again, what we're going to try to accomplish next time. So the idea behind it is that now that we have reachability from all the branch sites to each other and the data center over this new overlay subnet, we should be able to peer with the various locations with those IP addresses, which means we can have one instance of EIGRP running across the entire environment and peer with whoever we need to peer, and it'll just make our lives way easier to handle route steering and failover situations and stuff like that. So I'm going to stop here. Again, I'll put the link to the Cisco site for DMVPN in the description, and next video we'll pick up with getting rid of the redistribution and BGP and all that. Well, we can't get rid of BGP. I'll show you what I mean by that. But we can simplify things dramatically. So we're going to try to focus all our effort on one protocol, in this case EIGRP. And when we're all said and done, hopefully we'll be able to steer traffic way easier with the EIGRP. So I will see you guys on the next video.